In the preceding lecture, we discussed confidence intervals around a sample mean where the population standard deviation sigma was known. In this lecture, we will take that concept and apply it to the situation where we do not know the population standard. When we know the population standard deviation, we base confidence intervals on the z distribution. In this sigma unknown case, we will use instead the t distribution. The t distribution can also be represented with a formula with probabilities extracted from a table. The use of the t distribution requires that we know the degrees of freedom for the sample. The degrees of freedom is equal to the sample size minus 1. As the degrees of freedom increase, the t distribution approaches the normal probability distribution. In other words, the larger the sample size, at some point we can approximate the t distribution with the z. This is shown with a set of curves on this slide. When the degrees of freedom exceeds 100, the standard normal z value can be used to approximate the t value. To use the t distribution table and determine a probability, we need to know the degrees of freedom and the area in the upper tail, which for a confidence interval will be equivalent to the significance level alpha divided by 2. The formula to calculate the margin of error for this case of sigma unknown and using the sample standard deviation S instead of the population standard deviation sigma looks remarkably like the formula that we will use for the case of sigma known. But we will replace the z value for alpha over 2 with the t value for alpha over 2, and we replace sigma with the sample standard deviation S. It helps if we consider an example. We have a sample mean and a sample standard deviation, but no population standard deviation. We want to determine a 95% confidence interval for the mean rent. Given that we don't have a population standard deviation, we need to use the t distribution. That requires the degrees of freedom. In this case, a sample size of 16 minus 1 gives us 15 degrees of freedom. If we assume a 95% confidence coefficient, then alpha equals 0.05 and alpha over 2 equals 0.025, which would be the area in the upper tail. Using this table, we see that the t value for 0.025 and 15 degrees of freedom is 2.131. Inserting values into the formula for the margin of error yields a margin of error of 29.3. Therefore, we are 95% confident that the population mean rent will be within an interval of 750 plus or minus 29.3. The guidelines for sample size for the t distribution confidence interval are the same as for the z distribution. And for most business situations, we will assume that a sample size of 30 is sufficient. This diagram shows the logic of applying confidence intervals for the mean, whether we know the population standard deviation or that we don't know the population standard deviation.